The table below is your special values of the trigonometric functions. So you'll be given this table of values for your unit test, so you'll want to practice using this table on your homework. Okay, so recall that we have 0 degrees and 90 degrees, or 0 radians and pi over 2 radians. They're called quadrantal angles. So if we have our axes right here, and this is our y-axis, and this is our x. If I have a value of 0 degrees, that's right here. Okay? Well, this has no height, so therefore our opposite is 0, and our adjacent, so we'll say opposite, the opposite is 0 because there's no height, and adjacent equals the hypotenuse. So this is how we get 0 degrees right here. Now, with 90, if it's something like this, it's very similar, except there's no width. So now we have adjacent that equals 0, and our opposite and hypotenuse are equal. So they equal one another, which is where 90 degrees comes from. So pretty much this table, what that is trying to explain is that from 0 to 90, everything is covered in there. So all we need to know are the values of these 6 trig functions from 0 to 90 degrees, or from 0 to pi over 2, because they can be translated to all 3 other quadrants. And the only thing we have to consider then are the different sign values, meaning sign, S-I-G-N, not the trig function sign, but the sign, the negative in front or not. Okay, so the other thing that's important to know is that these are the special values. So we have our 2 special triangles over here to the right. And with these values, it's kind of, you can see that our 1 for cotangent comes from that triangle, and then it's pretty self-explanatory that we have our pi over 3 and our 3 pi over 3 if we did cotangent on our 60 degree triangle. And going beyond cotangent, the rest of these values come from the 30, 60, 90 triangle. And then with cotangent of 1, and the rest of this row goes to our 45, 45, 90. So this table pretty much comes from knowing these 2 triangles. Okay, so we're going to do some work with this and find the exact value for the trig function. So, sine of 225. So, what we first need to identify is that 225 is going to be in our 3rd quadrant. Well, why is that? Well, we know that over here we have 180 and down here we have 270 degrees. So clearly 225 is somewhere in between here. So this is our 225. So we know we're in quadrant 3. Now, the reference angle, which we've talked about before, is right here. So let's solve for that reference angle. Theta of our reference angle equals 225 minus 180. So this is going to give me a value in between 0 and 90. It gives me 45. So now it makes more sense of why we're finding reference angles, because before we were finding them so that it was in between 0 and 90. And now that we have this table that is from 0 to 90, we can figure out the exact value. So if we have 45, then something else we need to note is that our y value here is going to be less than 0, meaning sine is less than 0. So sine of 225, it doesn't equal the reference angle, it equals the negative reference angle of sine of 45 degrees. So you go to your table and you look for sine of 45 and you get root 2 over 2, but since we know that it's in the third quadrant and y is less than 0, it's actually negative root 2 over 2. Okay, so it might take a little bit, so let's look at another example. All right, tangent of negative pi over 6. Well, we need it to be positive, so first we need to actually find our coterminal angle. So our coterminal is going to be negative pi over 6, and we just add 2 pi to it. So if we want to have the common denominator, this is going to turn into 12, and this is going to be 6. So 1 minus 12 is 11 pi over 6. So now we have a angle measure in radians that is in between 0 and 2 pi. Well, we know that over here we have 2 pi, and over here we have 3 pi over 2. So 3 divided by 2 as the fraction is 1.5, and 2 is 2. So if we do 11 divided by 6, we get 1.83. So that's how we know we're going to be in the fourth quadrant. I'm just going to write it over here. I know the fourth quadrant's right here. So we're in our fourth quadrant. So negative pi over 6 is right here. So theta of our reference angle equals 2 pi minus 11 pi over 6. And this gives you pi over 6. Now again, we have to reference the fact that we're in quadrant 4, which means x is going to be greater than 0, but y is going to be less than 0. So we can go to our table and say, okay, tangent of pi over 6 which is going to be root 3 over 3. But now we need to adjust the sign. Well, since we have tangent, which is opposite over adjacent, which is y over x, and since y is negative, it's actually going to be negative root 3 over 3. Okay, so secant of 8 pi over 3. So the first thing to do is find the coterminal angle, because 8 divided by 3 is greater than 2. So the first thing we need to do is find the coterminal angle. So we're going to do 8 pi divided by 3, subtract 2 pi, and you get 2 pi over 3. So let's figure out where that is. Well, 2 divided by 3 is 0.66 repeating, and we know that pi over 2 is 0.5, or 1/2, and pi is 1, so we're in the second quadrant, quadrant 2. What we also know about quadrant 2 is that our x value, because since we have secant, we're dealing with 1 over cosine, so our x value is greater than 0. I'm sorry, less than 0. Because to get to this terminal point, you have to go left, which is negative. So we need to find our reference angle. Now, if I were to draw this a true 8 pi over 3, we would actually end here, but it would be a full rotation. That's why we had to do the minus 2 pi. So we pretty much just want to know the reference angle, which is this value right here. So our reference angle is going to be pi minus 2 pi over 3, which equals pi over 3. So pretty much what we did using reference angles was find the value between 0, pi, and pi over 2. So now that we have pi over 3, we can look at our chart. And what are we doing? Secant. So secant at pi over 3 is 2. And since we know that x, which is secant, or cosine, which is 1 over, secant, which is 1 over cosine, is negative, then it's actually negative 2. Now, cosine of 270, well, 270 is right here. We know this. This is our our quadrantal angle, if I could say that right. So since this is one of the 4 exact angles here, then we know that this whole thing is 270. And what that means then is that the cosine of 270 actually equals the cosine of 90. So we know that because, this is our reference angle from the x-axis. It's right here, which is 90 degrees. But I don't have to worry about the sign because the sign of x doesn't change at all. So since cosine is x, so if you looked at cosine of 90 on your chart, it's 0. Well, the sign of 0 can't change, so that's why we say the cosine of 270 equals the cosine of 90. And you also can think about it as, if you thought about the normal plane, there is no x move. There's no x shift to get to this point, you just go down. So x is 0 here, and therefore no sign change, so they both equal the same thing, which was 0. So cotangent of negative 120, so we need to find the coterminal angle first. So we need to do negative 120 plus 360, and we get 240. 240 is in between 180 and 270. So we're in quadrant 3, which means that x and y are both less than 0. But since we're dealing with cotangent, it's actually going to be a positive answer because cotangent, well, tangent is opposite over adjacent, so you'd have a negative over negative, which is a positive. So therefore, cotangent, adjacent over opposite, is also going to be positive. So our reference angle, which falls right here, is going to be 240 minus 180, which gives us 60 degrees. So then we consider these signs that we said before. So it'd be a negative over a negative, which gives you a positive value. So I could also say cotangent of negative 120 equals positive cotangent of 60. So then when you look at your chart, cotangent of 60 is root 3 over 3. And our last example. So our last example, again, we need to find the coterminal angle. So 13 pi over 6, and we need to subtract, sorry, that looks like an equal. Subtract 2 pi, and we know we need to do that because 13 over 6 is greater than 2, and we get pi over 6. So pi over 6 is going to fall in our first quadrant, and if we drew the angle, you go all the way around and then another pi over 6, so this is where it ends. Now, we're in quadrant 1, and if you remember with reference angles before, quadrant 1 is what we're basing all our reference angles after. So we just need to consider the sign. Cosecant is 1 over sine, so that means we need to take into account that y is greater than 0. So the reference angle of pi over 6 is pi over 6. Like I said, it's the same. So therefore, the cosecant of 13 pi over 6 equals the cosecant of pi over 6, which is positive 2.